Hello everybody. So in this video I'm going to discuss about a new topic, that is data type, right? Data type in the C. So this is the topic today I will discuss. So operator topic in the last video I have discussed. In between, actually data type concept from the beginning of the class it is required, but in the special operator, one operator type is the special operator. There the data type concept also required. So for that, here I am discussing the data type in C. It's very simple, right? So C is the first typed language. That means the data type concept is introduced first time in the C language, right? In the C language, in the C language, the data type concept introduced or introduced first time, right? Before that, whatever the programming language were available in those programming language, data type concept was not there. C is the first typed language. That means data type concept is introduced. Okay, so this is one point here I have written. What is the second point here? How many types of data types are there in the C language? So in the C language, they divided or classified the data types three types of data types are there. Three types of data types are in C. What is that mean? Number one, number A, primitive data types. Okay, primitive, it is also called as standard, also called as primary data type, right? Number B, derived data type, derived data types, right? And number C, third one is user defined data type. This three type of the classified, the data type is classified into following three types: primitive and derived and user defined. So primitive having alternate names are there, right? So under this primitive data types, what are the data types they kept? Okay, in primitive data types, right? Primitive. Okay, this one is the primitive data types. So in the primitive data types, 1 minute. In primitive data types, they kept first one is character, integer, right? Float, double, like this. Some data types are there in the primitive. In derived data types, there is pointer, array, and pointers, right? Here I will write better examples. Here I will write, then I will explain this primitive data types, right? And here derived data types example is array, pointer. Okay, array and pointer. And user defined is structure, union, enum. These are the several types of data types. So why this variety of data types are used in the programs? Very simple, because in our program we are using different type of data. Data in the sense, in our program I'm writing, suppose I'm using 10, I'm using, suppose 10 comma using 10.5 comma I'm using a, right? I'm using, suppose, the group of characters. A is a character here, right? Character means single quotations. Characters. I'm using group of character also. Suppose I'm using, um, roll number, ROLL, roll. Okay, group of characters like this. I'm using different type of data in the program. So to identify those different type of data, they introduce the data type. Because C language, in other programming language, the data type concept is not so important. In Python, data type concept is not so important. But in C language, Java language, C++ language, the data type concept is important because they designed the language in that way. So C is a typed language. Data type is most important. Which type of data you are using? Based on that data type you have to use in the program. So these are, suppose, example, one more example. Suppose I'm writing a big number, suppose 4 5 6 7 8 9, a big number. Suppose I'm writing mobile numbers, right? These are the collection of numbers. So this kind of things frequently I'm using in the program. So 10 is a integer data, 10.5 decimal point is there, so it will be treated as a floating point data. A is a character data, roll is a string data, and this is a very big numbers, right? 4 5 4 6 7 6 8 3. It is treated as a long integer data, right? So based on the requirement of using data or values in the program, they introduce the data type concept. And whenever we are using those values, those data in the program, it is mandatory that we should take care about the data types. Which type of data types it should be, we should know. That knowledge should be everybody has, right? So one more important point is what? Whenever I'm writing these values, this data in the program, those values, those data are consuming some memory in the computers. Some memory is consumed, right? Some memory is consumed. So remember, the computer memory measured in the terms of byte, kilobyte, megabyte, gigabyte, right? Already you know, whenever you are downloading any file, photos, any video, any song, already the size is mentioned, 4 KB or 300 MB or like this, some size. That is what is nothing but size or memory measurement, right? The memory in the computer, the memory is measured, right? The in the computer, I'll write here the point here. In the computer, the memory is measured in terms of byte, comma, kilobyte, KB, I'm short form I'm writing, megabyte, MB, gigabyte, GB, like this. Some memory measurements are there. Everything having measurement, mass, length, time, velocity, like this. Some measurement unit is there. So same way, memory utilizations also, it is measured in the term of this terminology: byte, okay, byte, kilobyte, megabyte, gigabyte, right? Terabyte, TB, short form is TB. Like this, some measurement unit is there. We can say it is the unit of memory measurement, right? Smallest unit of this memory measurement is which one? Smallest unit of memory measurement is bit. is bit. The smallest unit of memory measurement is bit, right? So this particular terminology, byte, kilobyte, megabyte, gigabyte, you know very well, because in your mobile phone also, in your computer also, everybody frequently using this term. Okay, using this term. But the smallest unit for this memory measurement is bit. There is some relations between byte, bit, kilobyte. I will tell that one. Okay, so one kilobyte or one byte equal to 8 bit. 8 bit. Similarly, 1 kilobyte equal to 1 kilobyte equal to how much byte? 1024 byte, equal to 1024 into 8 bit, right? Similarly, 1 megabyte, MB, equal to 1024 AB, which is nothing but 1024 into 1024 byte, which is nothing but 1024 into 1024 into 8 bit. Like this it will continue. Gigabyte, terabyte. Okay, so like this it will continue. One more interesting thing is that one nibble, okay, one nibble equal to 4 bit. Okay, 4 bit. One byte equal to 8 bit. One nibble equal to 4 bit. So these are the several measurement of unit, or measuring, I can say unit of measurement of the computer memory, right? So we have to focus on this. One byte equal to 8 bit. Most of the cases this concept will be used here, because every explanation is based on this one only, right? One byte. So this is some idea about the computer mm, memory measurement, right? Now I will tell about the data types and their storage capacity. Character, if I'll write a character value in the computer, how much memory it will take? Because frequently in the program we are writing like this: char ch equal to suppose x, like this I'm writing. If I'm writing like this, then how much memory will be consumed in the computer? Similarly, I'm writing integer a equal to 10, like this I'm writing. So whenever I'm writing like this, how much memory it will be consuming the computers? Let us have a discussion on that. That means the storage capacity of each and every data types, very very important, right? So give heading here: storage capacity of data type. Data types, storage capacity of data types, right? So storage capacity of data types, I will do one tabulation here, so that it will be easy to understand. Okay, so first one is, I will write here, okay, come to here in the paint software, I will write, then I will copy paste here. So storage capacity, right? First one I will write from the small storage. I will start. Character, CHAR, character. Character storage capacity is 1 byte. Okay, 1 byte is nothing but 8 bit. Okay, 8 bit. 8 bit. 1 byte, 8 bit. Then how much range of value I can store here? I can store here the value 256 value I can store. 256 values we can store. 256 values, right? So this character, again two types I told: unsigned unsigned character, okay, and another is signed character. Okay, unsigned character and signed character. So unsigned character only, no? So unsigned means only positive. Unsigned means only positive here, right? Unsigned mean here only positive values, right? So one byte, one byte. Here also one byte, because these are the character class under character, these two are coming, right? One byte. So what is the range, sir? The range starts from positive na 0 to 255. So total 256 values. Similarly, signed character means here positive will come as well as negative also will come. But one byte means 256. Maximum 256 values we can store. In that, among that 256, some value negative, some value positive. So divided by 2, it will come in the range minus 128 to plus 127. If I'll add 128 with 127, 255, and 0 is there in between. In the middle, 0 is there. So total 256 value. But unsigned means this is the range, signed means this is the range, negative as well as positive value. Right? One byte, only one byte character store. Whether it is unsigned character or signed character doesn't matter, but one byte will be consumed the memory. If it is unsigned, only positive. Positive means 256. How it is with 0 to 255. Become 256 values. If it is signed means negative as well as positive. So divide 256 by 2. So it will come minus 128 to 127. 127, why I have written? Because 0 is there. In between 0 is there. Minus 128, minus 127, minus 126. Like this 0, 1, 2, up to 127. So this is the about the character data types and their storage. Okay, I will add this one to the note. Now come to integer, right? Now next is integer type. Integer type, it will store, it will take consume, or it will take memory 2 byte. 2 byte. 2 byte is nothing but 16 bit. Okay, 16 bit. In the 16 bit, how much value we can store? In the previous case, I told na 8 bit, one byte character was 1 byte. 1 byte nothing but how much bit? 8 bit. In 8 bit, how much value we can store? 256 value we can store. How it is come to 56? 2 to the power 8 is nothing but 256. Similarly, here in this case, 16 bit means how much value we can store? We can store how much value? 2 to the power 16 value we can store. That is nothing but 65,536 values we can store here in the integer container or integer type. Right? In the integer type, we can store this much value. Right? Again, this integer is, I will tell, this integer is divided into signed integer. Okay, signed integer. It is signed integer, or it is also called as only integer. Only int. Int means signed int automatically by default. It is also sort int. SHORT. Sort int. So storage size is how much? Integer 2 byte. Okay, 2 byte. How much value? 65,536. But integer means, on signed int means negative value we can store as well as positive value also we can store. Right? I will tell that one. Size I will tell, range I will tell. Now second one is what? Unsigned. Just like before I discussed unsigned integer. Unsigned integer. Unsigned integer size is again 2 byte. Unsigned meaning is what? Only positive. Positive. 2 byte. 2 byte. In the 2 byte, how much value we can store? 65,536. So positive means the range starts from 0 is positive to, so total 65,536 na? 0 included. Then remaining is 65,535. So 0 to 65,535 value we can store inside the unsigned integer, as it is only positive. Unsigned means only positive. In the same way, signed integer or integer or short integer, here both positive as well as negative we can store. So divide by 2, the range will come minus 32,768 to 32,767. This range of value we can store in the integer data type, right? Integer data type. If I am writing in the program only int, that means it is a signed integer. Okay, that means it is signed integer, not unsigned integer. Unsigned integer means separately I have to write unsigned integer. Then it will be treated as unsigned integer. Then it will be treated as unsigned integer, right? Okay. Sir, suppose in the integer type, can I store 32,768? Can I store 32,768 in the data type integer A? Can I write? No, I cannot write, because A is a integer data type. Integer data type nothing but signed integer data type. What is the positive value observed? I can store 32,767, but you have written 32,768. Not possible. Some wrong output I will get if I write like this, right? Some wrong output I will get. Can I store unsigned int A equal to 32,768? Yes, I can store. Because why? Because observe the unsigned integer range 0 to 65,535, right? So we can store up to this much range, right? I will add this one to note also. Now coming to one more important point, sir. Suppose you told the range of this integer data type. Sir, suppose one employee is getting some salary. Employee is getting some salary. Suppose 20,000 salary he is getting. 20,000 salary he is getting. I want to store this 20,000 salary in a variable. Can I store in integer salary equal to 20,000? Yes, I can store, because range of integer is 32,768 minus 2, 32,767. Can I store in unsigned integer also? Yes, happily we can store. Happily we can store. Suppose one employee is getting salary 50,000 salary. Can I store this 50,000 in int salary? No, I cannot store, because integer is the signed integer. Its range is observed 32,767. Sir, can I store in unsigned integer? Unsigned, yes, I can store in unsigned, because unsigned range is 0 to 65,535. Right, I can store. Yes. Sir, suppose one more employee is getting salary 70,000, right? 70,000 salary. Now, can I store in 70,000 in unsigned integer salary? No, I cannot store. And integer also not possible, because integer range is 32,000 and unsigned is 65,000. But salary is getting 70,000. So in that case, suppose a employee is getting salary more than 65,535, we, in that case, unsigned integer also fail to store, and only integer also fail to store the value. Then in that case, what I have to do? In that case, the modifier again, long integer is there. Long integer is there. right? Long integer is there. In that long integer, how much memory it will take in the memory in the computer? It will take 4 byte, 4 byte memory. Okay, I will tell this one, long integer, long integer, right? Next, long long integer. Long integer memory storage capacity is 4 bytes. Sir, why long integer required? Because salary. Okay, suppose you are getting 1 lakh salary. Where I will store? Long integer I have to use. I cannot store in unsigned integer. I cannot store in integer because restriction of that is storage capacity is there up to 65,000. So 4 byte means how much value I can store? 4 byte means how much bit? How much bit? 8 plus 8 plus 8 plus 8, 32 bit. Okay, 32 bit. So how much value I can store? 2 to the power 32 value I can store. 2 to the power 32 is nothing but, what is the value? 2 to the power 32 means it will come 42949 67296 value I can store. Now 70,000 coming under this range or not? 1 lakh coming under this range or not? 2 lakh coming under this range or not? Okay, now salary storage problem is solved because nobody is getting salary more than this value monthly, right? Monthly. So it is a very big number. Nobody is getting this much salary monthly, right? So salary problem is solved. Nobody, maximum case. But if it is more than that value, some other options are there. But it is sufficient to store a very big number, a big salary also we can store here. So long integer solution given, which size is 4 byte, nothing but 32 bit. How much value we can store? 2 to the power 32. 2 to the power. Sir, why always 2 to the power taking? You are 3 to the power, not 4 to the power? Because binary, na, binary means 2. That's why 2 to the power, 0 and 1. 0 and 1. Okay, so this is the storage capacity for the long integer. Okay, long integers. So long integer, again it may be signed long integer. This long integer also called as a signed long integer. It is also called as signed long integer. And one more is unsigned long integer. Very simple, unsigned long integer. So unsigned long integer, again 4 byte, here also 4 byte, here also 4 byte, because long integer size storage capacity will not change, but range will be changed. It depends upon positive and negative values. So unsigned means only positive. Positive means it will store 0 to, okay, total this value na? So 0 will be included means 1 value will be decrease here. 42 949 67295, and here divided by 2, because half will be go to negative part, half will go to positive part. So it will come range minus 21474 83648 plus 214748367, right? Up to this range value we can store in the long integer, right? Long integer. So this is a note I will add there. Long integer range, this is right. Now come to next one. Okay, now it is a crucial moment to store the data. Suppose I am writing integer a equal to 10.5. Okay, if I will write like this and if I will print the a value percentile d, what answer I will get? I will get answer only 10. But what is my storage value? 10.5. That means it is the wrong answer, right? It is the wrong answer. So that means integer cannot store this floating point values. Floating point values. One example I will give. Suppose height. Height is generally suppose 5.5 inch. 5.5 inch. Suppose this height I will store in the integer h equal to, if I display h, what output I will get? Only 5 I will get. Sir, already 5.5 is a small value, and by storing in integer again it reduced to 5. That means this kind of values, decimal values, not allowed to store in the integer. What is the solution for that? Float data type came to picture. Float data type came to picture. In the float data type, we can store the decimal values, right? Floating point values. Then storage capacity of float is what? Floating point value. Float data type. Okay, float data type. Storage capacity is 4 byte. Okay, 4 byte. Nothing but 32 bit. What is the range? Range is, okay, range is 3.4 into 10 to the power minus 38 to 3.4 into 10 to the power plus 32. Here unsigned float, signed float, nothing, no terminology is there, only float data types, right? Float data types. Next, now the range is this one. The range is minus this much to plus this much. Suppose bigger than this number I want, bigger than this floating point number I want, then solution they given what? Long float. Long float. Also it is called as double. Okay. Storage capacity, 8 byte. Okay, 8 byte, and size is 1.7 into 10 to the power minus 308 to 1.7 into 10 to the power plus 308. This is the storage capacity, right? Storage capacity of the double. It is a big number itself. It is a big number itself. Suppose again bigger than that number I want, they given one more solution. One more solution for that is what? Long double. In the C language, long double concept data type also there. Storage capacity is 10 byte. It is a very big number we can store. You know what is the size? Size range of value we can store 3.4 into 10 to the power minus 4932 to 1.1 into 10 to the power plus 4932, 10 byte size, right? So in this storage I can store a very big number. This is the about float, long double data type, and corresponding storage capacity you need to remember, right? So this is all about the data type and their storage capacity. Storage capacity, right? So for this time, this much data type is enough. In the coming classes, we will discuss about the what different other data types are there. Now I told you this one, derived data types, right? Derived data type. This one, derived data types, array and user defined data types. Okay, all these things we will discuss slowly in the coming classes, right? So this is the data type used in the C program and their corresponding storage capacity, and why the different data types are required also I gave the examples here, right? So I hope this concept is understandable to you. 1-2 times at least you watch this video and try to remember all this range. Basically the character range, integer range, float range, up to that you may remember this one. So in the next video I will discuss some new topic. So till then, take care and bye.